Hello guys, so in this video we are going to start with the basics of R. So here you can see these are the topics that we are going to cover in this video. So you can see that with markdown that I showed you in the previous video, it becomes so easy and so readable. So yeah, these things are very useful. Okay, so let's start. So there is something known as a data type. So what I mean by data type is as follows. So let me define a variable, say A, and a is say equal to 1. Okay, so a is equal to 1. Okay, this is executed. I need one more tab here. If you see a, it says a is equal to 1. Okay, that's fine. Now if you see the class of a, so here class is a function, a predefined function in R, and it will tell you what class does a belong to, or in other words what is the data type of a. So it says numeric, means a is a variable that is having a numeric data type. One is a numeric data type. Similarly, say I can just write, say a1 is equal to 1. Now you see I have put quotes over here. Now these quotes mean a lot. When I just run this one and say let me see the class of a1, you see it's a character. So what's a character? A character is anything that is inside semicolons. So you can also write a b c d over here. So it's a string of words. So this can be words, this can be number, this can be anything. Okay, so these are characters. Any character. You can also have, say, hash over here. Okay, and when you print, let me just keep this as well. Okay, so you can see, you can just print that. Okay, this on the other hand was a number. Okay, so hence the type numeric. Okay, so like this, R has certain data types. Let me put them over here. So you saw a is equal to 1. Also, if you put L in the behind, so if you say a is equal to 1 L, now it'll say 1, but then the type of a has changed. Now if you see class a, it'll say integer. So the difference between integer and numeric is that integer does not has floating point values. So it will always be an integer, 1, 2. You cannot have 2.5 in an integer. Okay, as if it becomes 2.5, it will become numeric. Okay, so if you actually want to define an integer, you place a L behind it. That's it. Okay, so like this, there are certain data types in R. Let me just list all of them for you. So a is equal to 1, L is an integer. Okay, yeah, one more thing. If you put a hash over here in the code, then that means that you are commenting this. So this is just a comment. This will not be read by the compiler. It's just for notes or some, so that the person who has created the code can remember something. So I'll say, okay, this is an integer. Now b1, this will be numeric. C is equal to, say, a b c d. This is a character. You see, d is equal to, say, 1 plus 2i. This is a complex data type. Okay, so these are certain important data types that you should know. So you know when these codes are there, when these so this is basically a little high level. I mean, I don't know if you would actually require complex numbers, but yeah, this is the way how you can define or how a complex number looks like. Okay. So these are some data types. You can actually check the class of every data type and see that it's different. So for this, the class is complex, the character, numeric, integer, etc. Okay, so these are different data types in R. Then moving forward to the arithmetic operations. So you can use R as a calculator. Say x is equal to 10, y is equal to, I don't know, 5. So z is equal to x plus y. Tell me what z is. So z is 15. That's simple. So you can also do a lot of things over here. You can say divide. So when you divide, it'll be 5 divided by 5, 10 divided by 5, that's 2. You can multiply, that's 50. You can do raised to, so this is x raised to 5, so that is 10 raised to 5. So that is 1 into 10 raised to 5. So e is nothing, I mean, so this format, e plus is a mathematical format of saying this is 10 raised to 5. Okay. You can also replace this one with two stars. That will give you the same output. So this and this is the same. Okay, that is raised to, or to the power of. Okay, and then two these things are modulus. So it'll give you the remainder. So this says that when you divide 5 by 10, the remainder is 0. Similarly, if I put 11 over here, it'll say the remainder is 1. Okay, so this is for remainder. It will give you the remainder of the two things. Okay, so these are some basic arithmetic operations that you can use as it is in R. And then R has some predefined function. We have seen one function over here, that is a class function. Also note that whenever you want to use a function, you use round brackets for functions. Okay. Now the other functions that you can use in R, say x is equal to 10, this is a basic thing. Say log 10 of x. Okay, so this gives you the output 1. So this is log to the base 10. You can also have say log to the base 2. You can also have log to the base e, that is natural log. So this is natural log. If you want exponent, that is exp of 1, this is also predefined function. So log to the base e of e is 1. Okay, so these are some predefined functions. You can also have say sine x. So this will give you in radians. So actually sine pi is 0. Okay, so this is 0. Okay, something into 10 raised to minus 16, a very small number, approximately 0. Also see that pi is predefined in R. So this is predefined in R. So please remember, don't do something like this, because if you do something like this, then it overrides the pi value. So now sine pi wouldn't be 0. You get that? So pi is something that is predefined. If you write something over it, then it becomes a problem. Okay, so now the pi's value has changed. Okay, so this is a problem. So you can remove a variable by defining remove pi. So it will remove pi, and now you get the actual 3.14 back. Okay, so remember, so this is another predefined function to remove a particular variable or clear a variable. Okay, so these are different predefined functions and variables. So like pi is a predefined variable that you can use, and remember, don't use pi for anything else. Okay, or else you can, I mean, face a problem when you do something that actually requires pi. Okay, so these were some predefined functions and variables. Then you can also define vectors. So for now I was just using scalars. So x is just a scalar. Now actually I can make it a vector. Say 1 to 10. Let me just print x. So now x is a vector having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. And this colon operator will actually give you a list of numbers from 1 to 10. Okay, you can, I mean, define this, say 1 to 15, you get 1 to 15 numbers. Okay, very simple. Then if you want spacing, that is, say if you want to do something like this, you use the sequence function, and then you can say 1 to 10, and then you say by is equal to 2. I did not display it. Right, so over here it is giving you numbers with a spacing of 2. So 1, then a spacing of 2, then 3, spacing of 2, and so on. You can also change this with length. Say you want 5 numbers, so you get 5 numbers. So how many ever numbers, how many numbers do you want between 1 to 10, that you put over here? So 7, so here you'll get 7 numbers. Okay, so these are different ways by which you can make a vector. So you want to make a custom vector, so you use the combine function for this, that is C, just C. And say I want 5, 2, 7, 8, 10. So now here x is a custom variable with these values, a custom vector with these values. Okay, so that was about vector, how you can create a vector in R. You can use sequence, you can use the C operator. Also vectors have data types. So if when I'm putting A is equal to C 1 2 3 4, or let me make this 4 a little random. Okay, and when I do say class of A, you see it's numeric. So A also has a data type which is numeric in this case, but then you can also have something else. I mean, you can have, say, hi, this is also a vector. See, this is also a vector, is also valid in R, and if you see class of A is character. Now if you try to oh, I forgot one thing. There's one more data type called boolean, so I can have E is equal to true. This is a boolean data type. So by boolean, what you mean is E can either be true or false. So if you see class of E, it's logical. So this is boolean or logical. So this can either take 0 or 1. So there's either true or false, only two values. Okay, so yeah, so you could also have a vector with different data types. Say I put 1, say I put high. Oh no, let me put true. Also it's important to keep all caps, because that is what it wants. I mean, if you just place true, it will give you an error. A small true will give you an error. Okay, so you can also make sure that you have written right by the color. So you see, if it is right, the color changes. Okay, so say 1 true and 5.5, something like this. Now if you see A and if you see the class of A, here you can see it is numeric. There was a logical data type in the middle, but still it made it numeric, because the vector as a whole, A as a whole, can have only one data type. Okay, so here you are forcing two data types to be in the same A variable, which is not actually allowed. So what R does is R changes the data type to the most flexible data type. So over here the true gets changed to 1. If there would have been a false over here, oops, I made semicolons, that's my mistake. Then you see a 0 over here. So every false would have turned to 0 and true would have turned to 1, and the class would still remain numeric. Okay, now in the same case, if suppose you actually put a string or a character, say A. Okay, this is a character. When you do this, what happens is everything becomes a character. So here true false have also now become a character, and when you see class of A, it becomes character. Okay, so remember, I mean, so character is like the most flexible data type. Every data type can be converted to a character, but then your operations are gone. I mean, now you cannot do 1 plus 1 the mathematical. I'll just tell you what I just meant. So if you want to access, say I want to access 1 over here, how do I do that? You press A, you give square brackets and press 1. So like this you can access A. Okay, the elements of A. You can access the elements of A like this by square brackets. Remember, for the function it is round bracket. If class is a function over here, hence I put round brackets. But if it is a variable or a vector, see over here, C was a function, it is round brackets. But if you have a variable that is a vector, then you need square brackets. Okay, so A of 1 will give you 1. But if you do say A of 1 plus A of so this is 1 2 3. Also it's very important to know that R starts its index with 1. So you don't have A of 0. Okay, A of 0 does not exist. So you see A of 0 will give you nothing because it does not exist. You cannot have A of 0. So R starts its numbering with 1. So this is the first index, second index, third index, fourth index, fifth index. Okay. Okay, coming back, if I say A of 1 plus A of 3, 1, 2, 3, ideally I should feel I should get 6.5, but I get an error because non-numeric argument to binary operator traceback. Okay, so because these are like different, I mean these are strings, hence it is not able to add both of these. Okay, but the same thing if this would have been a numeric data type, you would have got 6.5. So now you understand the difference between a string and a numeric data type, right? The data type are very important. Okay, uh, the data type actually defines which function can be used. So these arithmetic operators that I just showed you, these arithmetic operators, they can only be used when the data type is numeric. Okay, right, so that was something. Then you can also say if you don't want to include 5.5, suppose, okay, you just want A of 1 2 and 4. So what you can do is you can say -3. So when you do -3, it will display all the elements except the element that is there in minus. So in some sense it minuses the third element. Okay, so you can also do -4 and it will remove the 0. You can do -1 and it will remove the first one. Okay, so this is also how you can actually control which elements you actually want to see from a particular vector. Okay, you can also store this to a new vector. So when you do this, now B will be 1 5.50. So I have -1, so the first element is gone. So like this. So if you actually want to only put a subset of some elements into B, then you can do like this. You can also put the colon operator here. So say 1 colon 2. So this will give you only the first two elements of A into B. Okay, so these things are also allowed in R. Okay, so I guess this was a pretty basic video on R, basics of R, and we'll continue. We'll stop here. This is enough for this video, and then we'll continue with the next video. Thank you so much for watching. Thank you.